We're going to continue our discussion on law of sines, law of cosines today, and we're going to talk about what's called the ambiguous case, and then we're also going to do some application problems involving law of sines and law of cosines. So let's start with the ambiguous case. So the ambiguous case occurs when two different triangles can be created using the given information. This happens when you are given an angle and two sides where the angle is not the included angle. So that means you have two sides in a non-included angle, so side-side angle. Technically, you could call it angle side-side, but because the abbreviation gives us something a little bit unfortunate, that is the side-side angle case. You can call it the donkey case if you would like. So here's an example. Say you're given these measurements. Measure angle C is 33 degrees, B is 10, and C is 6. Now there are two triangles that can result from this. So in the first triangle, so if you're looking at A, B, and C, those form one version, one triangle, where the side C, that's 6 inches, you can think of it as swinging outwards. In the second case, you can also have a triangle with the same measurements, but that side C is now swinging inwards, and so it creates the triangle A, B prime, and C. Now it's ambiguous because it's not clear which of those two triangles you have. So it's ambiguous, you could have two different triangles. Now this only occurs when these are the pieces of information that you have, and it doesn't always end up being the case where you have two different triangles. So how do you know if there is a second valid angle measure when you're solving one of these and you don't know whether or not angle B, if that is the only angle measure, or if there is another possible angle measure for angle B? Well, so here are the steps. So first, you're going to check to see if you are, in fact, given two sides in a non-included angle, so side-side angle, or the donkey case. If it's not that case, then you won't have two possibilities for angle B, at least angle B in the example before. Then, find the value of the unknown angle. So essentially, you're going to find and solve just like you would normally. Once you find the value of your angle, this is the part where you're going to determine whether or not you have two different angle measures. So you're going to subtract that number you just found from 180 to find the possible second angle measure. Now, to determine whether or not that second angle measure actually works, you're going to add that angle to the original angle measure that was given. If that sum is less than 180, then you have two valid answers. If the sum is over 180, then the second angle is not valid and you only have one possible triangle. Let's do an example. So this is the one that was given to you at the beginning to show you that there are two possible triangles. So let's see how it actually plays out when you do the calculation. So we have side B, side C, and we have angle C. So using law of sines, you would do 10 over sine of B is equal to 6 over sine of 33. Cross multiply, and then solve for sine of B. And now we need to solve for angle B. So sine inverse of 10 times sine of 33 divided by 6. And that comes out to be about 65.2. Now, we want to find out what that second angle measure is. Now, because we saw in the picture that this does in fact have it, let's see how it works mathematically. So subtract the 65.2 from the 180 degrees, and that gives us that the second angle measure, the possible second angle measure, is 114.8 degrees. Now, to check to see whether or not this is valid, we take the 114.8 and we add it to the original angle measure given, angle C. So 114.8 plus 33, if it's less than 180, that must mean that it does in fact work. So in this case, this is 147.8, which is less than 180. So this is a valid second angle measure. So there are two answers here. Angle B could be 65.2. It could also be 114.8. Let's do another example. Find the measure of angle A in the triangle with the given information. Angle C is 64, A is 8, and C is 10. So again, let's start by using law of sines to solve. So 8 over sine of A equals 10 over sine of 64. Cross multiply. Get sine of A by itself. And then we're going to solve for angle A by taking sine inverse. And this comes out to be about 46 degrees. Now to find the second angle measure, we subtract 46 from 180. So our second possible angle measure is 134 degrees. Now to check, we add that to 64, the original angle measure given. Now because 134 plus 64 is more than 180, we know this can't work because if two of the angle measures in a triangle add to more than 180, then we can't have a third angle in that triangle. So this doesn't work, and so the only valid angle measure for A is 46 degrees. Okay, let's move on to some application problems. Here's the first one. A plane flies in a straight line at 400 miles per hour for 1 hour and 12 minutes. It makes a 15-degree turn and flies at 375 miles per hour for 2 hours and 27 minutes. How far is it from its starting point? Let's go ahead and draw a diagram for ourselves. So here's the first part. Flies in a straight line at 400 miles per hour for 1 hour and 12 minutes. Then it makes a 15-degree turn and flies 375 miles per hour for 2 hours and 27 minutes. So here's the 15 degrees, mark that off there. And now it's asking how far is it from its starting point. So we'll draw a line from the starting point to the end point. So that's that right there. And that's what we're trying to solve for. Now let's see what we already have. Because we know that that angle there is 15 degrees, we can find one of the measures inside the triangle is going to be 165 degrees. And now we need to figure out the actual distances that are traveled. So because in the first leg it says that the plane flies 400 miles per hour, that's the rate, times the time, 1 hour and 12 minutes, and that will give us the distance. Now 1 hour and 12 minutes, you want to convert this all into hours before you multiply by 400. So 12 minutes into hours, you do 12 minutes over 60 minutes. So 12 over 60 gives you 0.2. So 1 hour and 12 minutes is 1.2 hours. 400 times 1.2 is 480. We'll do the same thing with 2 hours and 27 minutes. So this is 2 point something, so we have to convert the minutes into hours, so 27 over 60. That comes out to be 0.45. So this is 2.45 hours. Multiply that by 375. That comes out to be 918.75. So now we can go ahead and label that first part, travel 480 miles there, 918.75 miles there. And now let's label everything A up here. I'm going to label angle B down here, angle C here. And then we know across from angle A is 480, that's side A. And then across from angle B is the 918.75, so that's side B. And across from the 165 degree angle, that's side C, and that's the one that we're trying to solve for here. So if you take a look at the information we have two sides and the included angle. So here we want to use law of cosines. C squared equals A squared plus B squared minus 2AB cosine of C. So we have 480 squared plus 918.75 squared minus 2 times 480 times 918.75 cosine 165. And putting that entire thing into the calculator and then taking the square root, we get C is about 1,387.97 miles. We have one last example. a fence post is located 36 feet from one corner of a building and 40 feet from the adjacent corner. Fences are put up between the post and the building corners to form a triangular garden area. The 40-foot fence makes a 58-degree angle with the building. What is the area of the garden? Okay, so we definitely need to draw a picture for ourselves so we can understand what's going on here. So we have two corners of the building, and there's a fence post that's located 36 feet from one corner and 40 feet from the other corner. So here's the building. Here's the fence post. We know that this is 36 away on one side and 40 feet away on the other side. Now you can see that if we were to put up fences here between the post and the building corners, right, so right along these lines that I've just drawn, it forms a triangular garden area. Now the additional information that's given is that the 40-foot fence makes a 58-degree angle with the building. So look for the side of the building, look for the 40-foot fence, and the angle between those is 58 degrees. Now it's asking us, what is the area of the garden? So to find the area of the garden, we can either try to find the height of this triangle, try to find the base of the triangle, or pick one of those to be the base and try to find the height there. That might be a little more complicated. So let's see if we can use maybe the area formula that's derived from the law of sines. For that, remember, we need to have two sides and an included angle. Right now we have two sides, but we don't have the included angle. We have another angle in the triangle. But what we can do is we can use law of sines to find the measure of one of those angles. So let's label what we have. I'm going to call this angle A, this angle B, and this angle C. That means that 40 here is side A, and 36 here is side B, and then the building is side C. So using law of sines, I can find 40 over sine of A is equal to 36 over sine of 58, and this will give me angle A. Now angle A is still not going to be the included angle, but once we have angle A, we can subtract angle A and angle B from 180 to get angle C. So let's solve for angle A. Cross multiply, and then get sine of A by itself. And then to solve for angle A, we're going to take the sine inverse of that, and that gives us angle A is 70.4 degrees. Now angle C is going to be 180 minus angle A minus angle B. So angle C comes out to be 51.6 degrees. So now we finally have two sides and the included angle. So now we can use the area formula derived from law of sines. Area is equal to 1/2 AB sine of C. So we plug in 1/2 times 40 times 36 times sine of 51.6 degrees. Multiply that out, and that comes out to be about 564.26 square feet. And so the area of the garden is about 564 square feet.